Alright, you guys, welcome to Chapter 12, Lesson 6, the Law of Cosines. Now, you need to remember how to put an angle in standard position, just like this. This is called R, the hypotenuse. This is the X, and this is the Y, and this is your angle, theta. And what we learned was that the sine of the angle theta is equal to Y over R, and the cosine of theta is equal to X over R. Now what's interesting, something interesting will happen. This right now is simply X, Y. But if we solve these for X and Y, we can do a substitution and see something that happens. What we'll find is that Y is equal to the R times the sine of theta, and X is equal to R times the cosine of theta. So this XY point actually becomes R cosine theta times was the X value, and the Y value is R times the sine of theta. And this will be helpful to us in developing a new law, the law of cosines. Here it is. You'll need to memorize this situation right here. Here's our triangle. Any triangle that we can come up with. No longer required to be right triangles. We've got angle B, and angle C. Then across from angle A, we've got side A. Across from angle B, side B. Across from angle C, side C. So in any triangle, doesn't matter whichever triangle you're dealing with, we'll discover that C squared is equal to A squared plus B squared minus 2AB times the cosine of C. Okay, or B squared is equal to A squared plus C squared minus 2AC times the cosine of B. And A squared is equal to B squared plus C squared minus 2BC times the cosine of A. Now, this seems like it might be really hard to memorize, but the law of cosines, there's a pattern here. Let's look at the pattern. First of all, you're equaling a side squared in every situation. So it could be C squared, like this one. Could be B squared, like this one. Or it could be A squared, like this one. Let's go to the first example. When you do C squared, notice you do the other two sides squared. B squared, the other two sides squared. A squared, the other two sides squared and added together. Okay, so that's the same. So if you have C, then it's going to be A squared plus B squared. If you choose B squared, it's going to be A squared plus C squared. If you do A squared, it's going to be B squared plus C squared. Then you do minus. Minus 2 times, whatever these were, AB. Minus 2 times AC. Minus 2 times BC. I'm just trying to show you some of the patterns to make this easier to remember. And then finally, you multiply the 2AB, or the 2AC, or the 2BC, times the cosine of whatever the angle is across from the side you started with. So C squared, you got the cosine of the angle C. B squared, you got the cosine of angle B. A squared, you got the cosine of angle A. So look at that and make sure you understand those patterns, because that might help you remember. I'm not going to show how to derive this, but if you look in your textbook, you can see how to prove this is true by using this substitution for xy and the distance formula. Okay? So look on page 580 to find the proof. 580 to see the proof. I'll give you the brief rundown, but I'm not going to work it all the way through. The basic idea is if you take a triangle here, and this is side A, side B, and side C, this is therefore angle C. Here's the cosine. Now if you use the distance formula, this is B and this is A, then B will end up being A0, and this one will end up being B times the cosine of C for the x component, And then the y will be b times the sine of c, just like this. So that's why we did this first. We need to have found out this curious little fact and plug it in down here. And then if we find the distance formula of AB, it actually simplifies into this. And then you can repeat the process for each one of these. So look at page 580, you'll see the proof. What we're going to do with this is solve some problems. We're going to be able to solve the triangle, and remember, to solve a triangle, means you know all three sides and all three angles. Now we could do that with a right angle, but now we can do it with any angle, or any triangle, almost, using the law of cosines. So here's an example of how we would do that. Here's a triangle, ABC. ABC. So this would be side A, side B, and side C. Now, in the triangle ABC, if A is 10 and B is 13 and angle C is 70 degrees, find C to three significant digits. We can do this. Okay, so first, since we want C, we're going to use C squared equals, now let's remember the formula. C squared is equal to, okay, the other two sides squared and added. A squared plus B squared minus 2 times these, AB, times the cosine of the angle corresponding to the side we started with. There it is. So let's plug it all in and find what we need. So C squared equals A squared, 10 times 10, 100. B squared, 13 times 13 is 169. Minus 2 times 10 times 13 times the cosine of C. This is great. Okay. Oh, and C was 70 degrees. We can plug that in too. Okay, this is all calculator stuff. So you're going to get C squared is equal to 180.08. All right, now we got to square root it, and so we're going to get C is equal to 13.42. That's the answer. We only want three significant digits, it said, so 1, 2, 3. So the answer we're going to put is 13.4. That's the answer. Okay, let's do one more. This is the second example, and in order to do that, you've got to be able to change the law of cosines from side focus to angle focus. So here's what that looks like. You're going to end up with something like this. The cosine of C is A squared plus B squared minus C squared all over 2AB. Okay, so we're going to use this new version of the law of cosines to help us solve a different situation. Suppose you know all three sides. You know this is 50, this is 150, this is 120, and we want to know this guy. Well, we can do that. So what we'll do is we're going to say this is angle C, so cosine of C is equal to A squared. We'll just make this one A. So 50 squared plus B squared, let's say 120 squared, minus C squared, huge number. Then divide it by 2 times 50 times 120. So what we'll do is we'll plug in the calculator machine answers and we'll get this. Okay, then you're going to do the inverse of negative 0.4667, and then you'll end up getting 117.8 degrees. And that's it. That's how you do these. Okay, let me know if you have any questions, and I'll talk to you guys later. Thanks.